Okay, thank you. Dr. Niihara, it's a pleasure to have you. You're currently in Delhi, you told me. How's the
Yes.
weather there?
Oh, it's not too bad. I guess monsoon is keeping the air cooler than I expected, so this is very nice. Thank you.
Okay, so let's speak about your specialty. You dedicated your life's work in research as professor at UCLA in sickle cell anemia. So, and it's also not by case that you are right now in Delhi from LA. So, could you please a little bit describe sickle cell anemia for the people which don't understand the disease as a startup for our discussion?
Yes, sickle cell disease is a disease of red blood cells, and this is a genetic disease. Um, it is affecting a gene for something called hemoglobin that is within red blood cells. And actually, this gene had survived all these years, centuries and centuries, because having one gene actually is preventive of malaria. So in the area where malaria is quite prevalent, this gene survived and also flourished in a way. However, when the patient receives two genes, red blood cells become rigid and become deformed, and you know that the red blood cell is the one that carries oxygen throughout the body. And when it becomes rigid and deformed, it blocks the blood vessels. And when small blood vessels are started to blocked, then it's going to deprive the tissues from oxygen. So what happens is it's like having a mini strokes throughout the body, and it's quite painful, and it can affect brain, lungs, heart, liver, bone marrow, almost every part of the body. And of course, subsequently, it's not just suffering, but survival is quite shortened.
Okay, so this is a quite uh, painful disease, and to my understanding, it can also be fatal.
Mhm.
Um, how much is the prevalence in these diseases around the globe? I know that you will you are concentrating on India, on the United Emirates, and on Africa. How is the disease distributed, and how many cases we have worldwide, and who's affected?
Yes, right now this is just an estimate, but as we start testing these patients or screen them, we keep increasing this estimate. Currently, India alone, we are very certain that there is over 20 million patients, closer to 30 than 20. Africa is similar to India, and the Middle East, maybe 300 to 400,000 patients. But again, these are estimates. But as we, do more screening tests, this estimate seem to keep increasing. For example, like 20 years ago, our estimate for the whole world was only about 4 million. But now, a few years ago, it was readjusted to about 20 million throughout the world. But now, just India alone is over 20 million. So it's quite a few patients. It affects mostly people who live in the area called malaria belt. This includes the Middle East and, of course, parts of India. And Africa is mostly central and western part.
And just a question. We know also that we have a lot of malaria occurrences, like in Indonesia or something like this. I remember from traveling there as I was young, like 8, 9 years to Bali, that I have to take Lariam all the time. So that made me sick in the morning. Just as sickle cell was basically one genome prevents malaria or makes it like this. Is also Indonesia one of the countries with high occurrences?
Actually, not Indonesia. Indonesia does have another form of a disease, hereditary disease of hemoglobin, not sickle cell disease. Sickle cell disease, this gene was believed to have occurred in three major areas, in the areas that I covered. Malaria belt does extend toward Indonesia and northern Philippines, and of course, some of the Southeastern Asian countries, but yeah, it doesn't extend to those areas. Instead of sickle cell disease, many of these patients have thalassemia and a few other mutations of hemoglobin.
So, as it is a disease which hits a lot of people, especially in the developing world, in Africa, and in worlds where wealth is not so distributed, like in India, and also really rich countries like the United Emirates. So, how's the access to treatment options, and what kind of treatment option exists?
Yes. Well, we have known about this disease for centuries, and but medically, this was really identified under microscope about 100 years ago, and actually this was discovered by student. And then in late 1940s, 50s, Linus Pauling and Harvey Tunnell actually analyzed this from genetic level, and this is the disease that was first ever to have the sequencing done on the disease or the mutation. However, the treatment development hardly occurred. um, in the meantime, there was a treatment for like a number of diseases like diabetes, blood pressure. There was a treatment for pernicious anemia, but no treatment for sickle cell disease. We call this anti-sickling medications. Nothing was available until 1990s. And this is a little bit odd because, medications were developed for almost any common disease in different parts of the world, but nothing was done or nothing was developed. So in 1998, repurposing of chemotherapy called hydroxyurea was developed. And this is a treatment that causes cancer because it's a treatment for cancer. Ironically, treatment for cancer frequently also causes cancer. But because of lack of anything else, and this disease is so devastating like cancer, this treatment was accepted for adults anyway. And then the next time anti-sickling treatment that came out was from us. I started my work in 1992 at UCLA at the Linguist Institute. And we had proof of concept by year 2000. I was funded by National Institutes of Health and the FDA. And we proved that our medication can actually decrease hospitalization and something called painful crisis and number of other complications of sickle cell disease. And this was approved in 2017. And this happened to be the second time anti-sickling medication was ever approved for adults, and the first time ever for pediatric patients. Since then, few other anti-cyclic agents were approved. I won't name them, but these medications cause so much side effect. One of them was actually already taken out of the approval. The other one is still out there. However, because of toxicity, not too many patients can take it. Now, recently, gene therapy has been getting a lot of attention, gene therapy, CRISPR therapy, and it's really a good thing. Of course, when this works, it can actually cure sickle cell disease, and this is really nice. However,
But the cost would be extremely high.
cost is extremely high, and also what we call conditioning therapy is quite harsh on patients, and it's definitely not applicable to most patients, even in the United States, and certainly not in the developing countries like countries in African continent or in India, because it really required tertiary medical center to apply this therapy.
So speaking about your treatment option with L-glutamine, um, can you tell us a little bit about the efficacy from L-glutamine
Yes.
and how, I mean, I saw some nice microscopic pictures how blood looked after a while of treatment, and it looks like mechanically everyone bound the red blood cells again in the right form. So what happened there and why does it happen?
Yes. Thank you for asking for this. Um, Many of the investigators realized that the problem, one of the major problems
I
in,
am sorry when I'm looking there, you because you are here on the monitor, not in front of the camera. So when I'm looking down, I'm actually looking at you. So
okay, that's fine. Yeah, yeah, it's okay. So what happens is with our treatment is what we're looking for something that can prevent oxidation damage to red blood cells because pioneers have realized that one of the major issues with this mutation is that it causes enormous amount of oxidation, which also damage the red blood cells. So we wanted to find something that will prevent this oxidation. And we realized that the internal antioxidant system is going to work the best. So I'm going to cut the long stories and just tell you that we realized that glutamine was what's missing in this natural antioxidant system that we already have within the red blood cells. So when we supplemented these red blood cells with pharmaceutical-grade glutamine, we saw that the hardening have stopped, damage to red blood cells stopped. That's the reason why you saw this so like um, a healing of red blood cells or um, reversal of this sickling effect, which causes a hardening and the deformity of red cells into more normal shaped red cells. So this is what we saw in the laboratory. Clinically, what we saw is that the patient who used to be hospitalized almost every week no longer had to be hospitalized, and people who are having what we call painful crisis, and this is really, really devastating situation. They require so much narcotics to get themselves sort of relieved from this severe pain. But the number of crises have gone down. What we define as crises have gone down by almost 50%. And there are patients who still had crisis, but the severity of crisis was significantly reduced. There are a number of other parameters that we have looked, but in every parameters, this was a consistent. Every time we treated the patients. And the best part of this is that we found out that this is probably the most effective anti-sickling agent, and it has hardly any side effect. Most of the treatment that was approved in the past by sickle cell, even if these were taken down, they had something called like a black box label because some of the toxicity was quite severe. But we did not have to have this black box label because there was hardly any side effect. In fact, in our study, what we call a major side effect or major adverse event, it was hardly ever related to the use of the medication.
thank you. Let's speak about cost efficiency. I mean, L-glutamine versus the other disease medications.
Yeah.
How cost efficient is to produce L-glutamine? What is the quantity? And then we go a little bit in the distribution channel of it.
Okay. So we have let's say extremes. The medication-wise cheapest extreme is the one that was developed in 1998, hydroxyurea. It's just the cost of medication and pills. And the other extreme is like a bone marrow transplant or CRISPR therapy. Um, bone marrow transplant and CRISPR therapy, these are not available to most patients and they're enormously expensive. We are talking about like $5-6 million. And then hydroxyurea, it costs only maybe a few cents a day. So that part is really nice. But because it causes side effects such as bone marrow suppression, which usually requires transfusion or hospitalizations, and because of this complication, they'll have to have blood testing quite often, like every month, if you're on this medication.
So
And
basically, you have to take the blood test into the calculation of the final
that's
price.
right, yeah. And then, of course, there's hospitalization related to use of these medications. So by the time you add all these things up, right now, our treatment is most um, effective pharmacoeconomic therapy, in other words, cheapest, relatively speaking. Now, this is with the price of the new medication. Just recently, the exclusivity with the orphan drug designation came off. So we should be able to get down to a generic price pretty soon. And that's what I want to do because I want to make this available to everybody, not just the US patients, but patients in rural areas of Africa or India. And the Middle East is relatively rich, especially GCC countries, but still, if you keep the price at so like a brand name level, it's really hard for government to support the full price. So I'm working on pricing that makes sense for NGOs, governments, especially governments who facilitate this type of treatments in the patients in the rural area.
Thank you. So, when you highlight the benefit and how this treatment functions, can you also highlight the cost benefits for investors? What are the benefits for profit for investors looking for affordable impact solutions?
Okay, I'm going to start with the social aspect of this. First of all, patients are going to have much less complications and much less damage to organs, and they're going to regain some of the times lost for studies or work because they don't have to be hospitalized or have to stay in bed at home because of this painful crisis. So there is like a social cost gain. But on top of that, actual government spending is going to decrease. By our calculation, even at the relatively high brand name price, US government was going to save about 50% of the medical costs for these patients. Now, for the investors, we are planning to really make this medication affordable to many patients, as many as possible. But still, we'll be able to get enough margin for the medication to make it like profitable. So, because the market is so huge right now with millions and millions of patients, there should be the benefit from the profit to the investors once this gets going. Now, the treatment, the reason why this is so effective is I have mentioned before, but there is no complications. And actually, if you go into rural area, it's hard to find doctors or established medical centers. But you don't require these medical centers to administer this medication because there is hardly any side effects. So even the nurse or like minimally trained medical workers can bring these medications to patients without really worrying about the adverse events due to a medication.
So,
So
how is this medication administered?
it's administered orally. It's a powder mixed in fluid usually, and then it's administered twice a day.
So
Orally.
basically,
Orally.
like one of the sparkling vitamins, which I just take in the
Yeah,
morning.
exactly. Yeah,
Okay.
yeah. So yeah, it's like soft drinks,
Yeah.
except yeah, it doesn't. Well, it has no taste, so it's helpful for some of the kids if you mix with the chocolate milk or some juice or something. But you can mix in like I take it myself sometimes, not for other purpose, but it's a tasteless powder, and it's not that difficult to take. certainly much easier than many of the narcotics that they have to take for pain if they don't take this medication.
So what are the problem with the current supply chain of this medicine within
So,
India, UAE, and Africa?
yeah. So when we discovered that L-glutamine definitely is going to help, and I'm talking about the pharmaceutical grade L-glutamine, and the distinction between pharmaceutical grade and supplement grade is very, very important because supplement grade does not have any really a regulation for the authorities to really check what's in the bottle. However, the medical grade, they have to go through a stringent regulatory process and stringent purification process. And actually, only one plant in the whole world can produce this. And the amount that they produce, of course, it's used for many other purposes too. But when we discovered that this is useful for glutamine, first thing that we all worried was how are we going to provide this medication even to 500,000 patients? Because current production is 2,000 ton a year, and every 100,000 patients, we need about 1,000 ton. And so 200,000 patient is going to use up all the L-glutamine that is being produced today in the world. But as I said, India alone has over 20 million patients. So then we have to produce, if this treatment becomes appreciated and accepted, most likely we'll have to build more plants that will produce this. So that is something that I'm looking into very, very carefully because it's really, really unfortunate that this very effective and simple medication is not available to many of the patients because we don't have enough supply in the world. Fortunately, we're getting a lot of good, enthusiastic support from different government that we speak to. If this start to spread, many of the governments are willing to work with us to build more facilities.
Yeah, it's also, can you re-emphasize here, the supply from the medical grade L-glutamine is only 200,000 ton. Of course,
Right.
there
And
is other
2,000 pounds.
supply
Supplement
which is
grade.
available for L-glutamine, but this
Mhm.
is basically useless. And I know from our prior discussion, could you also tell what are, for example, what are the risks for taking
Yeah.
generic medicine, generic glutamine?
Yeah.
What could happen?
So generic glutamine is okay as long as it's medical grade, but anything less than medical grade, which is what's available in the supplement stores, some of them are actually pretty good, although it's not as good as a medical grade. But when I was working with the FDA, one thing that we were quite worried and FDA was quite adamant about is that we should not go to supplement grade because amino acid, when supplement amino acid is used on long term, it can cause accidents. And one of the biggest accidents that we saw was in late 80s with the tryptophan, which was promoted for inducing sleep. And a lot of supplement grade tryptophan was used, but just one batch had some impurity that caused a lot of death, and many people who didn't die still suffer from the consequences of this toxicity. And this happens because the regulation is very lenient or non-existent for the supplement grade products. And it's not just the amino acids like glutamine, but then many other supplements are known for causing actually quite severe side effects and a lot of times death. And these are well published. But because supplements are so popular, and in many cases supplements are helpful, it's really hard to change the current system of marketing supplements.
Currently, we have basically already spoken a little bit about this supply chain issue, which means we don't have enough product to treat even all the patients in one country, India alone, and neglecting the majority of patients being in Africa. Now, there is already this supply chain issue. Your company, your fund, invests directly in the supply chain, increasing the supply chain. And it is a fund which really improves the wellness of a lot of people. My question is, it's good to invest in something which does good. But of course, investors want to see also the 10x or higher return. So what is your strategy to change in the supply chain to satisfy an ethical growth of your company, of the companies and the whole market?
Yeah. Oh, as a starter, in the past, actually, there were two companies, both were Japanese companies that were producing this pharmaceutical grade L-glutamine. And at the time, sickle cell disease was not one of their target. So then demand was not very high still. So one that was run by Kyowa Bio, which is under the umbrella of Kirin Beer, they decided to get out of this pharmaceutical grade glutamine business. We were fortunate because we were able to purchase the plant that they have decided to leave for very, very inexpensive price. We do have to retrofit this once we have sufficient funds, but this is going to at least double the current availability of glutamine once we start producing a glutamine here. But even then, it's not going to be enough. It's hardly enough. So as the demand starts to increase, we really have to look into other possibilities. We could increase the capacity of our plant that we bought in Japan because there's ample space to build a few other manufacturing so like units on the same land. But when I talk to like African governments or Indian governments, they're actually interested in like having the plants in their own countries. So that's going to be for the future, but I'm seriously looking into this to make sure the supply is there. In terms of financial return, the financial return is not bad at all. If you can run 2,000 ton production every year, then that's going to bring a good return. Now, you said 10x, 20x. In terms of the value of the company, what's interesting is that one medication which hardly increased the so like its utilization in the United States, and this is one of the medicine that was causing so many side effects. That company was sold for billions of dollars. So you can see that there is an interest among investors for treatment of this disease. And myself being a physician scientist, it's just like once you start with one medication for one indication, over the years, you keep coming up with new ideas and new indications with the same medications or other medications. And I myself, while during this tenure developing this medication, I came up with several other patents, which most likely is going to be quite effective for reversing some of the conditions.
Dr. Niihara, we are out of time.
Okay.
Thank you very much. It was always nice to speak to you. And we're saying goodbye to Dr. Niihara, one of the leading experts, or the leading expert for sickle cell anemia, professor in Los Angeles at the famous UCLA, and founder from different initiatives to fight sickle cell anemia globally. Thank you very much, and we are continuing Digital Davos with David Doss, manager and founder from CKC Fund. And I see he is already online. Dr. Niihara, thank you very much. And
Thank you very much.